Hello and welcome back. So last time we had just seen two more properties, two more algebraic properties of limits just before my video recorder ran out of space. So when we have the limit of functions being multiplied together, we can just multiply the limits, and when we have functions being divided, we can just take the limit of the numerator and denominator. Again, provided that we're not dividing by 0. But division can be just turned into multiplication using this trick. We can turn g of x into g to the minus 1, and here we have multiplication. So we can pull apart multiplication using L4. This property here, where we multiply, we can pull it apart, and then when we have g of x to the negative 1, we can just write that as the limit of g of x to the negative 1 using one of our properties from before with the exponents. And again, limit of something times the limit of it to the negative first power. This is the same thing as division. This is just 1 over the limit. So everything that we've seen this far can be we can just use limits properties 1 through 4, but it's nice to write property 5 down by itself. So let's find this limit here. We have the limit of x squared plus 2x minus 15 over x minus 5, and we're looking at the limit as x approaches negative 5. So let's get to work. So this limit, we have something on the top of a fraction, something on the bottom of a fraction. So let's use our last property, and we'll say that we've got the limit as x approaches negative 5 of the top. And of the bottom. Cool. So now I've got the limit of the top of the fraction and then the limit of the bottom of the fraction, and we can only do this if this limit down here isn't 0, which we can see that this limit shouldn't be 0. It should be negative 10. But let's continue to use our properties and actually prove that. So the top of this fraction, we've got the limit of a bunch of things being added together. So let's take the limit as x approaches negative 5 of x squared, plus the limit as x approaches negative 5 of 2x, minus the limit as x approaches negative 5 of 15. Okay, so that's all three terms on the top of the fraction, and I want to divide all of this by the limit as x approaches negative 5 of x, minus the limit as x approaches negative 5 of negative 5. So for this first equality, I used L6, which is L5, which was to divide, which is about division. Next, I split apart all of these. Addition and subtractions using, maybe I'll write this on this side, I believe this was L3, where the limit of two functions added together is just the individual limits being added together. And now there's a few more steps. So up here I've got the limit as x approaches negative 5 of x squared. So again, I can write this as the square of the limit. Here I've got the limit of 2 times the limit of x, of 2 times the limit of x. And the limit as x approaches negative 5 of 15, well, this is a constant function, so this is always just 15. Likewise, on the bottom of the fraction, the limit as x approaches negative 5 of x, well, This is just a tautology. As x approaches -5, x approaches -5. And then we have the limit of a constant function again. From here, so which properties did we use? Firstly, so we pulled the square out, so that was L2. We pulled apart the multiplication, and we saw that constant functions, the limits of constant functions are just that constant, which is the very first property. And then we also did the limit of x is just whatever we're approaching, and that was the one that's not mentioned in the book, but I wanted to give it a name. So we're nearly there. The limit as x approaches -5 of x, well, that is just -5, and we'll end up squaring that. The limit of a constant function is just that constant. The limit of x is just whatever it's approaching. And then on the bottom of the fraction, we've got -5 minus -5. Again, we used our constant function property, and then the property of the identity function. And this is just something we can simplify. -5 squared is 25, minus 10 minus 15, all divided by -10, and our limit is 0. What a coincidence. So we did a lot of work here using all of our properties, and we just got 0. When if we were to come up here and actually study this limit, what you'd notice is that if we plug in -5, we get 0 divided by -10. So why did we have to go through all that work if we could just plug it in? And the answer is we don't have to, or I should say we don't have to anymore. This theorem is exactly what we wanted and what will be useful. If f of x is a rational function, meaning a polynomial divided by a polynomial, and f of a exists, then if you take the limit as x approaches a of this function, you can just plug it in. That's all you need to do. So from this point on, if you want to take the limit of a rational function, you can just plug a in, and as long as that exists, you're good to go. If it doesn't exist, there's more steps, but we'll get to that in a little bit. So here is our same function again, same function that we're taking the limit of. The limit is x approaches -5 of x squared plus 2x minus 15 over x minus 5. So first of all, we need to answer the question, does f of -5 exist? So let's plug in -5 into here. So I'll take -5 squared plus 2 times -5 minus 15 over -5 minus 5. Simplify it. Again, we get 25 minus 10 minus 15 all over, let's just simplify that, -10. The top of the fraction is 0. The bottom of the fraction is -10, so this whole thing is 0. So yes, it does. So this limit, x squared plus 2x minus 15 divided by x minus 5 is going to equal f of -5, which just happens to be 0. So we don't have to go through all of the work of using our algebraic properties when what we're given is a rational function, which is very, very nice. Now let's do this for another function as well. So let's say that I want to take the limit as x approaches -5 of the square root of 2x squared plus 5. This is not a rational function. This is not a polynomial divided by a polynomial. If we have the square root of something, what we have is not a polynomial, let alone a rational function. So what we'll do is I'm going to use one of our properties, and then we'll see that we have a rational function. So if I want to take the limit as x approaches -5 of the square root of 2x squared plus 5. What I'll remind you is that the square root of a function is just that function raised to the 1/2 power. And we have a property of limits that deals with exponents. So this is in fact going to be the limit as x approaches -5 of 2x squared plus 5. And then we'll just take the square root of the entire thing, of the entire limit. And this is with the property L2, I believe. Okay, so now I just need to take the limit of 2x squared plus 5. And what we'll notice here is that, just as an aside, in sort of our scratch work, 2x squared plus 5 is a polynomial. So this is a rational function. So what can we do with rational functions? We can just plug the limit in as long as it exists. And clearly, if I plug a -5 into here, I can square it, take it times 2, and add 5, and nothing goes wrong. So this limit, I can use our theorem and just plug in our value. So this is going to be equal to the square root of 2 times -5 squared plus 5. And if we simplify this, -5 squared is 25, times 2 is 50, so it's just going to be the square root of 55. And that's all we have to do. Here's our answer. So we had to use one of our properties first, because the square root of something is not going to be rational. But once I use that property, now I have a rational function, and now I can just plug in my value. So that's quite nice. And then in the last couple minutes, I want to look at this guy right here. So I have a rational function. I have a polynomial divided by a polynomial. So the question is, can I just plug -5 into here? And the answer is, well, we'll see. Let's just try it. What happens if I plug -5 into here? -5 squared plus 2 times -5 minus 15 divided by -5 plus 5. Well, the top of the fraction, this is going to be 25 minus 10 minus 15 divided by -5 plus 5. Well, that's 0. And if I reduce the top of the fraction, I get 0 divided by 0. And, okay, I can't divide by 0. So I can't just plug -5 into my limit now. What are we going to do? Well, the answer is we're going to use some algebra, just like everything else in this section. So what I'm going to do is I'm going to take what we're taking the limit of, and I'm going to apply some algebra to it, and I'm going to show you that this is actually a lot simpler than it looks right here. I can't plug -5 in because I get something divided by 0, but I can simplify this fraction. X squared plus 2x minus 15 divided by x plus 5, the top factors. The top will in fact factor to x minus 3 times x plus 5. And here, I can cancel an x plus 5 off the top and the bottom, and get that this is equal to x minus 3. I still can't plug -5 into this function, because I can't plug -5 in, because I'll end up dividing by 0. But these things are equal for all x that aren't -5. So anything that's not -5, I can plug it into this function. What I'll do is I'll continue this in the next video, but I'll show you that provided that we can simplify our function, it shouldn't matter, and we can now just take the limit of x minus 3.